Hi everyone, welcome to EMC2GO. This is our second video, and today we're having a second KeyTek CEMASTER from US, and it's not working. And today we're going to tear down and repair this unit, and we'll have a look at what's inside. Here we go. Now we have the second CEMASTER KeyTek, and it's not working. So I'm just showing that we have the power here, which is the 240, and we'll plug this one in. So this is the EUT side, system power. Okay, let's power up the unit then. Nothing happens. So with the other unit, this is the old unit. Okay, so it does power up. So we'll try to open this one and we'll see what's inside. Okay, we'll open this one. So we have to be careful when opening this one, because this side here will hit the main board. So I have to hold this one while pulling this cover off. Okay, we'll have a look at what's happening inside. So we can see that this coil here, I think this was damaged during the transport, or because it's already it says it's not working. And so this relay here is damaged, that relay. So where is the contactor here? Oh, here we go, here it is. Okay, so must be somewhere here. This is fitted like this with the relay cover. Okay, we'll just put this one aside. Okay, we're going to fix this one, but as of now I'll show you what's inside of this unit and some of the function and part of it. Okay, so this part here, this one here, this is the filter for the system power supply, and this is the system switch mode power supply, which powers up all the display and the microcontroller. So the surge is coming from one of these, the bottom side. It goes into this main board. So these two inductors here, this is mainly used for decoupling, to prevent the surge from going back into the main supply. So this is the relay for the surge. When you turn on the surge on the front, EUT on the front, this will activate the relay, allows the EUT power to pass through the front of this system. So this one here is the big contactor, which also coming from the EUT power from the mains. So the other unit has a different contactor, which is rated only up to 10 amps or 125 volts maximum. This is rated up to 240 volts, 16 amps. So on the surge, these two guys here, which is the big high voltage capacitors, this is a 5 microfarad capacitors. This is the charging system. This is the charge for the high voltage. And these two capacitors here, which is the 10 microfarad 2 kV, this one here is the discharge capacitors. So, or the shaping capacitors. This will shape the waveform of the surge to make it 50 microsecond waveform. So in conjunction with the other resistor underneath, we will pull this board apart, and I'll show you what's inside of the behind of this board. So the shaping capacitors and also with other resistors. And we will see where is the 2 ohms for line-to-line discharge or surge, and also for the 12 ohms line to earth surge applications. So that is behind on this this upper board. So this one here, this big inductor here, this is the auto transformer. This one has a multi-tap transformer which has a 80%, 40%. There's also 70%. This is mainly used for voltage dips interruption. And the tap is selected, is connected through, so you can see that the transformer is connected to this board here, which is through a relays. This relay will select which tap when you apply a voltage dips interruption or the PQF. This relay will activate, depends on which tap of the transformer is selected. Let's say if you select 70% dip for 10 millisecond, so this corresponding relay of these will activate to apply that dip. So these guys here, this is IGBT, or insulated gate bipolar transistors. So with the bridge diode, there's a couple of bridge diode here. So there's also a IGBT here, and this is IGBT. This is used for clamping the voltage down to the dip. So this bridge rectifier allows the AC to dip only for the half of the cycle, or the half of the waveform, let's say plus or minus, and then it goes into the clamping IGBT. So there's a couple of relays here. This is the relays that we use when selecting when you apply between line to line or line to ground. This corresponding relays will activate, depends on which application is applied. So this is just an overview of what's the whole circuit on the top. And if you wonder why I understand about this, because I do fix the EMC, the KeyTek EMC Pro Plus and the Pro unit. So in our I do fix those units, especially those plug-in boards. The EMC Pro Plus and the EMC Pro is quite easy to fix because there are plug-ins. There are a couple of boards with plug-ins. One's for the PQF, the other one is for the housekeeping, and there's also one for the surge, and there's also one for the EFT. So we'll have a look inside at the back of this unit, and I'll show you where it is the high voltage, programmable high voltage is generated to produce the surge. Okay, so now we have here, what we have here is this is the AFT, high voltage generator, which is the fast high voltage transistor switch. These two inductors here, this is for the for the surge and for the shaping of the surge, and this is resistors here. This is for the, that is 1 ohm resistor. This is a 2 ohms resistor for the line to line, and this is 11, so this is a 12 ohms resistor here. So this one here is the programmable high voltage for the surge test. This is for the surge, and there's a couple of relays here, which is mainly for the AFT. So this is the AFT. So this is the AFT discharge transformer or balance transformer. So there's a couple of relays here. This is mainly used for the charging system, for charge and discharge of the big capacitors, charging capacitors. And I'm surprised that this board here doesn't have this mercury switch. With the EMC Pro Plus or EMC Pro has the mercury switch. And also I can't seems to find the reed switch, high voltage reed switch in this board. So they mainly relies on the relay, the big relays for the discharge or for the high voltage. Yeah, I can see here this is 100 meg. This possibly this is a resistor. This R27. So I can't see a reed switch, high voltage reed switch here. The EMC Pro and EMC Pro Plus has a reed switch for changing the polarity. I'm not quite sure how this one works on changing the polarity. So for the plus and minus from here, I can see that's going through the bridge diodes, and this one possibly has changed the polarity by itself, but the EMC Pro and EMC Pro Plus only has one output polarity, and changing the polarity, it goes to a reed switch. And yeah, that's all. I think that's all about what's inside of this system. And next is we're going to fix the main board with the damaged relays and the other bits. So we'll check if this relay coil is still working. So we have on the 200 ohms resistance. Okay, we'll fix this one. We'll place a glue. the next thing is to fix the coil using a 5mm drill bit to increase the size of the hole to allow a larger size cable tie to secure the coil and to solder the lead of the coil. Now we have this cable tie strap to secure the coil. Okay, we're going to assemble this one now. Okay, so it seems like it's powering up. So it's working. Surge. Yeah. You can set a user define or 2 ohms, 1000 ohms, sorry, 1000 volts. So you set it to direct. Random, I should start. Yep. Seven, 6, 5, 4, 3. We'll see if this one will fire. Yeah, I'm not sure which relay that's firing. Okay, that's good. So next one is just exit this one. Let's try EFT number 1. Oh dear, the selected option is not installed in the system. So there's no EFT 3. There's no option for number 3, which is power frequency, that's the magnetic field. And ESD, also no option for that. It seems like it's only surge, right? What about PQF number 5? Also there's no option for PQF. Pulse magnetic 7. Access required, enter access code. Oh no, sorry, that's calibration. So 6, also no option. It seems like it's only surge as well. So what I can do is I will try to see and find Where is the option chip? Okay, this is the main controller board. So it's very discrete components, and we'll try to look for some option chip that we can, because that other unit has, this one is complete, has all the options, and if we can find a chip, we'll try to swap the chip. Oh, okay. It says there, options, KeyTek. Must be this one, right? Okay, so this is seems like it's option out too. So we'll try to get that other unit chip, and we'll try to swap it if we can get this this one's working with all the options. So the good thing with this one is it has the 240 volts AUT input, which I can do testing on the 240 volts Australian products, which is Australian 240, whereas this one is only maximum 125 volts, 10 amps on the AUT. So powering up this one by 240, it's likely to damage the PQF board or the voltage dips and interruption board. So I have to make sure and check later on. It's the next project, next video, and we'll try if I can upgrade this one or change this one to 240. So I will have 2 units working. So for now, we'll work on the option. Okay. So now we have changed the I'll try to power up this one. And let's check for the surge. Yeah, working. And EFT, which is number 1. Oh, beautiful. So I have the complete option, I guess. Except number 3, which is power frequency, user defined. Yeah, perfect. That's working. And number 4, yeah, is the simulator not connected? I have that simulator, so that's all good. That's working. Number 5, which is voltage dips and interruptions, perfect. User defined. Yeah, you can set this one. Now if you run, it won't. It looks for the mains, so that's all good. So, and number 6, pulse magnetic, user defined. Yeah, perfect. And system setup, and that's all. I think that's all. Which is number 3, which is diagnostic. Line sync. It's looking for the mains. Obviously, I didn't connect the mains, so that's high voltage check. So before we end this video, we would like to check for the surge pulse waveform, just to verify if this unit is all working. So here we have we tested up to 2.5 kV. We set the factor to 1000. We have this times 1000 differential probe. We set the surge, user defined, 2 ohms. We'll set it 2500 volts, which is the maximum for this unit, and direct. So the phase angle or the reference we'll set it to random because we don't have the AUT input yet. So in the later time, so if you have the AUT, so we'll try with testing with the actual product. So number of tests will just say just 5, just in case if we repeat the test. So let's see, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, that's perfect. So our peak waveform is 2.46, so which is good. This is within 20% of the peak value, which is acceptable, defined by the standard. So if we check the pulse width, I will stop that. Select. So pulse width is from, I think the new standard defined is from 10% to 50%. So 2.46, 2.5 is 1.25, around 1.25. So 52 microsecond, which is good. Thanks for watching our repair and tear down for today, and in the future we will cover a lot of EMC stuff, especially when understanding about 1.2 50 microsecond, understanding about 820 microsecond for the surge, and what is 8 and 20 microsecond, and what is 1.2 50 microsecond, and understanding also the waveform of EFT waveform and other things. And we will build some of the project, like in the future I'll show you how to build CDN, or coupling decoupling network for DES6. So for someone who wants to do their own pre-compliance test in-house, or if you want to do some testing on your own. So we'll build a lot of things. We will cover a lot of things on CDN, and also I might show you how to use a spectrum analyzer and a signal gen to measure impedance. And thanks for watching. I'll see you next time, and don't forget to subscribe, hit that notification bell, and leave a comments if you have any questions. And we will cover a lot of EMC standards and compliance and all these things, and how to do some in-house pre-compliance, understanding about filterings and all these things. Okay. Thanks for watching, and bye for now.